So the last topic that the book talks about this week is recursion. And recursion is just a term for a function that calls itself, or a function that calls a different function that calls the first function, and so on and so forth. And we're going to see some examples of recursion later on when we start dealing with the document object model. And the document object model is a recursive data structure. So you have elements which contain other elements, and those elements contain other elements, which contain other elements, and it actually forms a tree. So here's the tree, and inside the body tag, there's some other tags, and inside of some of these tags are other tags. Let me actually go to a more complicated page. So let's go to yahoo.com, and I'm going to go to the debugger and go elements. And so here, if I open the body, inside the body there's some div tags, and inside the div tags are some other div tags. Inside of those div tags are other div tags, which have other div tags, and so on and so forth. So this is a big, complex, hairy tree. And if you want to write a function that's going to walk through all the elements in the tree, what you want to do is write the function to go through each element here, and then call that same function on each of the things inside. And when you call that same function on each of the things inside, it's going to go through each of the elements here, and then call the same function on each of the things inside, and each of the things inside of that, and each of the things inside of that, and so on. So you're calling the same function over and over and over again on smaller and smaller portions of the document until you get down to the individual tags that don't have anything inside of them, and you're done. So the basic structure of a recursive function is it has two parts. The first part is you have to know when to stop, because otherwise you're just going to keep calling yourself over and over and over and over again until you actually get an error because there's only so much stack space. So you need a termination condition, and then the other thing you need is a recursion step, which takes some portion of the input or some simpler version of the input and calls itself recursively on that. So the classic example of a recursive function is n factorial. So n factorial is defined as, for example, 5 factorial is defined as 5 times 4 times 3 times 2 times 1. And 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And we write n factorial like so in math. This doesn't actually work in JavaScript, but that's how you would write it in math. So how would you define n factorial in a fairly clean way? Well, one way of doing it is n factorial is equal to n times n minus 1 factorial. So for example, 5 factorial is equal to 5 times 4 factorial. And then 4 factorial is equal to 4 times 3 factorial, 3 times 2 factorial, 2 times 1 factorial. And then when you get to 1, you stop. So that's the termination condition. So you can define n factorial in terms of n factorial. And we can do the same thing in JavaScript code. So here I'm going to define a function factorial, and it's going to take a variable n. And the first thing we're going to do is give it a termination condition. So if n less than or equal to 1, that means we're done. And 1 factorial is defined as 1. Otherwise, we're going to return n times factorial n minus 1. There. So there's our n factorial. And now let's try it. So 1 factorial is 1, 2 factorial is 2, 6, 24, 120, 720, and so on. So each step of n factorial is calling n minus 1 factorial until n gets all the way down to 1, and then we just terminate. We return 1 and we're done. So there's a really simple example of recursive factorial. And as I said, we'll see this later on when we start walking through the document object model.